All right, everyone. So let's go ahead and take a look at some of these first questions. So the first one here just wants to find f of 9. So we're just going to take 9 and just plug it into my equation here. So the square root of 9 is 3. So we have 2 plus 3. So we did 2 plus the square root of 9. Square root of 9 is 3. 2 plus 3, that would be 5. So no big deal there. Second one. So now we're finding f of the quantity x minus 2 squared. So we're going to take this entire thing, x minus 2 squared, and we're going to plug it into x right here. Okay, so we still have that 2 floating out front, plus the square root of x minus 2 quantity squared. All right, so let's try not to overcomplicate this when we simplify it. We have a square root of something that's being squared. So anytime you're square rooting something that's being squared, you can just drop the squared there. Okay, those are inverse functions. They're undoing each other. So now I just have 2 plus x minus 2. So 2 minus 2 is 0. So I'm left with just plain old x. All right. Now, part B, there's a couple different ways that we could do this. So f inverse of 4. So when I'm looking at this, I don't have an equation for f inverse. I only have an equation for f. So I can't just take this 4 and plug it into x. Okay? So I have two options. Option 1 is I could find an equation for f inverse. Okay, we know how to do this. We switch the x and the y's, we solve for y, and then we'd have an equation for f inverse, and then we could plug in 4. Or, if we're creative, we can kind of figure out something to do with this 4. So what do we know about inverse functions? We know that with an inverse function, how do we get it? We got it by switching the inputs and the outputs. So this 4, even though it looks like an input, is really an output on my f function. Okay? So instead of plugging it in for x, we can plug it in over here for f of x. So we can say 4, oops, Okay, so we can say 4 is equal to 2 plus square root of x. Okay, because this 4 is representing an output on my f function. So then I can just solve for x, subtract 2, and then square both sides. So 4 equals x. All right, so that means that f inverse of 4 equals 4. There we go. All right, so now in part C, we want to find an equation for f inverse. So this will be good because we can check that answer that we just found. So we want an equation for f inverse. So what's my strategy? Well, I'm starting with f. My equation for f is y equals 2 plus the square root of x. And so we said our strategy for finding the inverse is to switch the x and the y's and then solve for y. All right, so I can do that. So x equals 2 plus the square root of y. And I just have to solve for y. So subtract 2. And then I'll take the square both sides to get rid of the square root. So it'll be x minus 2 quantity squared equals y. And so this is my equation for f inverse. So f inverse of x equals x minus 2 quantity squared. Now, if you got that answer, that's great. But I'm trying to make sure we understand, make some connections here. So let's see if we can make some connections, because there's a couple we can make. So if I go back up, first thing I can do is I can check part B. So part B says f inverse of 4. We said it's equal to 4. So to check that, now that I have an equation for f inverse, I can just plug in 4. 4 minus 2 is 2. 2 squared is 4. So I feel pretty good about that. Okay. Also, did you notice in question 1 part A, we plugged in x minus 2 squared and we got x back out. And look, f inverse of x is equal to x minus 2 quantity squared. So why is it not surprising that x minus 2 quantity squared is the inverse of f based on what happened up here? Well, if you remember from our notes, we have a definition And our definition says f of f inverse of x is equal to x. And that's what happened up here in part A. We took f inverse, which we didn't know is the inverse at the time, but we took f inverse, we plugged it into the f function, and we got x, which is what this definition said should happen. So after part A, we should have already kind of known that this was the inverse function. But we weren't really quite thinking about it like that at the time. All right, so now we want to know the domain and range of f. All right, so let me rewrite my function. So f of x, 2 plus the square root of x. Now, we have a couple strategies here. Okay, you guys have gotten much better at finding domain and range if you have a graph. But instead of just throwing it in the calculator, I want to see if we can reason through this first. Because that's really where we need to be ultimately, is we need to be able to reason through by looking at the function, finding some red flags. All right, so if I look at this function, what am I worried about? I see a square root, and I know that if I throw negatives under a square root, I'm going to have a non-real value. Okay, I'm going to have an imaginary number. So when you look at this function and you're thinking about domain, in your head you should be thinking, I can't have negatives in the x value, which means negatives are not in my domain. Okay, what about 0? Yeah, 0 is fine, right? The square root of 0 is 0, so that's all good. So positive numbers, excellent. Don't have to worry about positive numbers. So in just normal terms, your domain is 0 or positive numbers. So then you just have to remember how to write that. So the domain would be all the x values contained in 0 included, so we use a bracket, and then all the positive numbers for forever, so 0 to infinity. Okay, now what about the range? So again, we could throw this in the calculator, but let's see if we can reason through it for a second. So think about what you just said for the domain. You said I can plug in 0, I can plug in all the positive numbers. All right. Now what's going to happen to this square root as I start plugging in bigger numbers? If I plug in 1, I get 1. If I plug in 4, I get 2. If I plug in 9, I get 3. So as I plug in bigger numbers, this square root of x is getting bigger. Okay? Is there any way for it to get smaller? Is there any way for it to become negative? No. Like I can't plug in negative numbers because we said that's not in the domain. So this value, square root of x, is just going to get bigger and bigger and bigger as I plug in bigger numbers for x. So what is the smallest value in my range then? Well, the smallest value in my range should be when I plug in 0. So when I plug in 0, square root of 0 is 0. 2 plus 0 is 2, which means the smallest value for my range is going to be 2. So my range starts with 2 included, so I use a bracket, and then since the square root of x just keeps getting bigger and bigger and bigger, that means my range is just going to keep getting bigger and bigger and bigger. Okay, so that's the thought process there. Now, if you're not quite comfortable with that, we could grab a calculator and throw it in until we get more comfortable with that. So we have 2 plus the square root of x, and let's see what this looks like. Okay, so we can see that my domain is all positive numbers, and it looks to me like 0 is included. Now, how can I test to see if 0 is included? Well, you could go to the table. You could go second table, and you could go all the way to 0. Oh man, that's going to take a minute. Or, interruption.
Good morning, Fairmont staff. Today is Thursday.
All right, sorry about that interruption. So I just went into my table setup and changed my start value to 0. Okay, so it looks like 0, 2 is included. Okay, now if 2 wasn't included, you would get an error like you did at negative 0.01. Okay, another way you could do that, just some calculator information for you. If you just hit trace, and let's say your calculator starts over here somewhere. If I want to know what's happening at 0, I could just hit trace and then hit the number 0 and then hit enter, and it'll tell me what that output value is. Okay, so I feel pretty good that 0 is included in my domain, and then for my range, it looks like this is increasing for forever, and the smallest amount is 2. Okay, so using a calculator, not a bad idea, but ultimately we would really like to be able to kind of reason through this. All right, now piecewise. So my ultimate goal is to find the domain and range. We have some numbers we have to plug in. So let's start with the numbers here. So f of -4. So the biggest task you have is to figure out where to plug in -4. Well, -4 is less than 1, so I'm going to plug it into this top equation. So I have -4, which is +4, minus 1, so that's equal to 3. So first one's just 3. F of 8, well, 8 is more than 1, so I'm just going to plug in 8 to this bottom equation. So 8 squared is 64, plus 1, that'd be 65. All right, so not too bad there. You just have to know how to read these piecewise. All right, so part C says graph F. So let's see if we can do this just by kind of reasoning through it. I'm going to actually make some tables here. So if I make a table for -x minus 1, so think about what I'm doing here. I want this graph when x is less than 1. So I don't need to graph a ton of values here, maybe like -1, 0, 1. I don't need to do anything more than 1 because I only want this graph when x is less than 1 anyways. So I'm going to plug these values in. -1 is 1, minus 1, 0, 0 minus 1, -1, -1 minus 1, that's -2. And then I'll go over to my graph, plot these points, -1, 0, 0, -1. And then at 1, notice it just says less than. So when I graph 1, -2, I'm going to leave that as an open circle. Ooh, boy. That was bad. That's all right. Just make your dots bigger. All right, so there's my linear function. And then the next one is maybe a little bit tougher. So let's go and make a table for him. So x squared plus 1. So x squared plus 1. Now, I only want this when x is greater than or equal to 1. So I'm not going to spend a lot of time making a table. I just need the general idea of what this looks like. So I'll plug in 1. So that gives me 2. Plug in 2, that gives me 5. Plug in 3, that gives me 10. And I'm just going to plot those points. Now notice this is x is greater than or equal to 1. So when I plot my point 1, 2, that's going to be a filled in circle. When I plot the point 2, 5, counting is hard. 1, 2, 3, 4, 5. I hope that's 5. That'll be embarrassing. Okay, and then we have this is some sort of quadratic going up, 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 up. Okay? All right, so there's my graph. Is it beautiful? Not really, but it'll get the job done for what I need next, which is domain and range. Okay, so let's start with domain. So remember, domain is all the x values that are included. So when I'm looking at this graph, I'm going to start at the far left. I'm going to see what is my smallest x value. Well, this graph's going all the way to the left forever, which means my smallest x value, we're going to -infinity. All right, now I'm going to sweep my way to the right and see if there's any values that are skipped. I'm good, I'm good, I'm good, I'm good. Okay, so this is the part where I would have to double check. I have an open circle at 1, which makes me nervous for a second, but it gets filled in up here, so I'm good at 1. I'm good, and this is going up and to the right for forever. So my domain is -infinity to infinity, or all real numbers. All right, and then for my range, same idea, except I'm going to start from the bottom and work my way up to the top. So what is the smallest y value that I see? Well, there's nothing down in the negatives too far. So this -2, that's the smallest y value I see. And since it's an open circle, I'm going to use parentheses. So -2 is the smallest y value. And I'm going up, 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 up. Looks like there's some funky stuff going on here, but all the y values are still hit. Up, 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 up for forever. So -2 and then till infinity. Okay? So hopefully this video was helpful. If not, we'll set up some office hours or something. Part 2 is coming up here shortly.